Hello students and friends. In this particular video I'm going to solve question number 3 of the sample paper of the subject code 9701 paper variant 04 which was given in the year 2022. Now I'm going to solve question number 3 of that paper, which consists of questions from chemical kinetics. So let's go ahead. So this question number 3, I'm reading it. The initial rate of the reaction of chlorine dioxide ClO2 and fluorine is measured in a series of experiments at a constant temperature. So this is the reaction between chlorine dioxide and fluorine. It gives 2ClO2F and the results are shown in the table. So you have 3 experiments which have different molar concentrations of ClO2, fluorine, and for each experiment the initial rate of the reaction has been given. For row number 2 it has not been given, and for row number 3 the concentration of ClO2 has not been given. The rate equation is given by rate equal to K, the rate constant, times the concentration of Cl2 times the concentration of F2, which thereby means that this reaction is first order with respect to ClO2 and it is first order with respect to fluorine, and overall it is second order. And with the help of this rate equation it is possible to find out the value of the rate constant if the other values are given. Similarly, some other terms can be found out and calculated if the other related terms have been given to us. So the first part of the question is explain what is meant by order of reaction with respect to a particular reagent. And this is a simple question. The order of reaction is simply the power to which a concentration term is raised in the rate equation. So this being the rate equation, the concentration term here is raised to the power of 1, so it is first order with respect to ClO2. Now use the results of experiment 1 to calculate the rate constant K. For this reaction include the units of K. So we have to calculate the rate constant K. So if you rearrange this equation, you get K is equal to the rate over the concentration of ClO2 times concentration of F2, and we can take the values from the experiment 1. So the rate is 2.20 times 10 raised to minus 3. The concentration of ClO2 is 0.010 and the concentration of fluorine is 0.060. So when we substitute these values into the rate equation, we get the answer as 3.66 because here the number having the least number of SF is 0.060 or 0.010, which have 2 SF. So our answer should also be in 2 SF. So 3.66 can be rounded off to 3.7. And now working on the units, when we write down the units for the terms which have been used in the formula, this unit is given here, mole dm raised to minus 3 second inverse, and these concentrations are in mole dm raised to minus 3, but it is squared, so this becomes mole squared dm raised to minus 6, which cancels out to dm raised to 3 mole raised to minus 1 and second inverse. So this is these are the units for the rate constant K. In the third part, we have to use the data to calculate the initial rate in experiment 2. So now, having already found out the value of K here from this, we can plug in the value of K here, but we should not take the rounded off value. We can round off at the end. So we can take this value 3.66 the concentrations of ClO2 and F2 can be taken from experiment 2, which are given over here, and on solving we get 5.49 times 10 raised to minus 3. But once again we have to answer in 2SF because this number has only 2SF, so this is rounded off to 5.50 times 10 raised to minus 3, and that's the initial rate of the reaction. In the fourth part, use the data in table 3.1 to calculate the concentration of ClO2 in experiment 3. So if you go to experiment 3, this is the term to be calculated. The other these terms have been given. The value of K we have already found as 3.66, and when we have to find this out, we use this formula, and when we plug in the values taken from experiment 3, we get the concentration of ClO2 as 0.048 mole per dm cube to 2SF, because this term is having 2SF. So that's the answer. What is meant by the rate determining step? The slowest step. Whenever there are multi steps, there may be a slow step, there may be some fast steps. The slowest step in that multi-step reaction is called the rate determining step. Now here we have to suggest the two equations for the mechanism of this reaction between ClO2 and F2, and now it has two steps. What could those steps be? Now how are we able to arrive at these two steps? That is what I'm going to explain. We have to take into consideration the given overall reaction. The given overall reaction is 2ClO2 plus F2 gives you 2ClO2F, that you can see from here. That is the overall reaction. So this reaction is the overall reaction. We should take that into consideration. And we should take into consideration the rate equation which has been given, because the mechanism that we write should be consistent with the rate equation. So the rate equation shows that in the slow step we should have one molecule of ClO2 and one molecule of F2, and so when we write the step 1, we should include this ClO2 and F2 and make it the slow step, so that the rate will be proportional to the concentration of ClO2 and F2, 1 mole each, which will be consistent with the rate equation. So we make this as the first step, and we get ClO2F2. If we combine them, we get ClO2F2. But then we have to remember that ClO2F2 is not the product. As you can see, the product is ClO2F, not ClO2F2. That means in the second step we must have a reaction in which ClO2F2 gets cancelled. So we include that in the second step, and we can cancel this from both the sides. But we can also notice that we need 2 moles of ClO2. We have taken only 1 mole of ClO2 in our step 1. So we must include 1 more mole of ClO2, so that we are in fact reacting 2 moles of ClO2 in the final equation. So this F2 has already been included, and then finally we should get 2 moles of ClO2F, which you can write over here, and these two terms get cancelled, and upon addition we get 2 ClO2 plus F2 gives you 2 ClO2F, which corresponds and is consistent with the final equation given. So these two can be satisfactorily be considered as the two steps of the mechanism which are constant with the rate equation. So the first step, being the slow step, is the rate determining step, and because this is consistent with the rate equation, therefore these two steps are justified. Hope you understood this. And the last part of this question is, describe the effect of temperature change on the rate of a reaction and the rate constant. As you are aware that whenever we increase the temperature, the rate of the reaction increases, and the rate constant in fact is a direct measurement of the rate of a reaction. So if the rate of the reaction is increased, it automatically means that the rate constant has also been increased. So both the rate of the reaction and rate constant will increase as the temperature increases. These were the all the sub questions in question number 3, and hope you were able to understand properly. All the doubts got cleared and you understood uh, the solution of the question number 3 of the sample paper which was given in the year 2022 for paper number 4. Thanks a lot for watching, and do share and with your friends and comment and like. Thanks a lot.